Well, all right, ladies and gentlemen, today we're going to talk about linear regression. The difference between linear regression and linear recursion is really quite simple. Linear recursion, we know that there's a pattern we're looking for. And that pattern basically allows us to write the rules by hand. Linear regression means we're trying to find a trend, some idea of how the data is flowing. But we don't know if there's really a pattern. So we're trying to find what's called a best fit line or a trend line. And that trend line may not be exact. It may be estimated in order to use some kind of prediction for future values. That's linear regression. Now, something that we're going to have on linear regression is R. R is the correlation coefficient. R can be between -1 and 1. The closer R is to the value of 1, the stronger the correlation is. The stronger, the better the trend line is. The closer it is to 0, the weaker it is. Okay? So what we're going to do is we're going to take this information and we're going to type it into the calculator. When we type it into the calculator, we're going to get y equals mx plus b. That's our linear equation or our function rule. And we're going to get r. And r is our correlation coefficient. So we're looking for the function rule and the correlation coefficient so we can describe these data sets and then maybe predict what's going to happen in the future. So, take a second, put this information into your calculator. If you need to pause the video, you can right now. Okay, that should have been long enough for you to pause the video. So you put this into your calculator, and you're going to get y equals -2x. Actually, it's not going to be negative, and that's my fault. Got a little bit ahead of myself. This is going to be y equals 2x, and b is 0. So if you want to put plus 0, you can, but it is unnecessary. We do not need to write plus 0. But you're going to see that r equals 1. That means each one of these points is on the line. It is so super strong, there's no space between the best fit line and the points we're given. Super strong correlation. R equals 1. Now I want you to take the time, put these numbers in your data set. Pause the video right now. That should have been enough time for you to pause the video. So whenever you do this, you're going to get your values for M and B. It's going to be y equals -2x plus 7.6. And notice those are some estimated values here. Then you're going to get y equals -0.985. Negative 0.985 means this has a negative correlation, a negative direction. And 0.985 is really close to 1. So that means the line and the points are very close together, but there's still a little bit of space. Still a little bit of space. Now I want you to take the time to put this data set in. So what we did now is we took the data set and we made it some sort of real life scenario. The temperature outside versus how many cans of soda are sold, let's say at a ball game or something. So take your time. Temperature is the independent, so it's the x variable. Cans is the dependent variable. Cans depends on the temperature outside. So put this in the A column or the X column on your calculator and this in the Y or the B column in your calculator and calculate your linear regression. Go ahead and pause the video. Okay, that should have been enough time for you to pause the video, get that stuff in the calculator and hit submit. Figure out what your best fit line equation y equals mx plus b and what your r is. So what y'all should have gotten here, y'all should have got y equals 3.8x minus 147.2. And r is equal to 0.981. So this tells you it's a very, very strong correlation. It tells you it's positive, so it's going up. When the temperature goes up, the number of cans goes up. This is calculating linear regression with given data sets. Now, something here real quick. Couple different R values that you'll see. You might see R equals negative 2, 0.284. R equals 0.537. R equals negative 0.782. R equals 0.111. These are different R values you might encounter, or types of R values. So I want to look here and see what it means. What is it saying to us? This here says that it's negative. And 0.284, that's real close to 0. That almost rounds to 0. This is a weak linear relationship. A weak linear relationship because it's close to 0. 0.537. Well, it's a positive, so that's good. And it's not real strong because it's 0.5. It's like halfway between 1 and 0. So we're going to call this moderate strength. Moderate strength. Here, negative 0.782. Negative 0.782. Negative. Negative. So this has a negative direction. And 0.782, now that's getting pretty close to 1. So that means this sucker here is strong. And 0.111, positive 0.111. Well, it's positive. But guys, it's almost 0, which means it's weak. Very, very weak. Guys, that is linear regression.